In this problem, the potential energy is given as a function of position. So we need to find the position where the force is zero or at equilibrium. So basically the problem is presented in a complicated way. The potential energy function for a force between two atoms in a diatomic molecule is approximately given by this, where A and B are constant, x is the distance. So basically potential energy and the distance relation is given. We need to find the equilibrium position or the position where force is zero. Okay, so let's do this. So for equilibrium, the net force must be zero. So du by dx is zero. We have learned this. So we are calculating the derivative of this function. Okay, so how are we calculating the derivative? A x to the power minus 12. This by 12 we are converting into exponents, and also this. Okay, so we need to find the derivative of this quantity. So x to the power minus 12 we can find the derivative using the x to the power n formula. D of dx x to the power n equal to n x to the power n minus 1. I hope you all know this. This is just mathematics, simple mathematics. So minus 12 x to the power minus 13 minus b minus 6 x to the power minus 7. That is what it is done here. So now it becomes a simple equation, and we can accordingly find the value of x. So this x is the point of equilibrium. Okay, so what is our answer? Our answer is this, 2a by b whole to the power 1 by 6. I hope this is clear. This is a very common problem. You will encounter this kind of problem in almost all kinds of books. Okay, so I hope this is clear. Thank you.